Okay, so good afternoon, everybody. My name is Alexander Nyssen. I'm from itemis in Germany, and I'm a committer on the graphical editing framework project at Eclipse. And I want to speak about the next version of GEF we have started to develop. I want to give you a short overview on what our plans and our roadmaps are and what's actually currently there. I want to start with a quick motivation of what led us to the creation of that. So let's first take a look at the graphical editing framework itself in its current version, which is 3.9. The first thing that we can say about GEF is that it has birthday this year. So GEF is actually 10 right now. The GEF code base, basically the two components are Draw2D and GEF model view controller, which make up 2/3 of GEF, were contributed by IBM in 2002. There's a third component called Zest, which is for graphical visualization, which was contributed to the GEF project in 2007. That was developed in a university context in Canada beforehand and was then contributed to the Nyssen project and then finally came to GEF in 2007. But the basic code base was already there in 2002. So GEF is nearly as old as the platform itself. The current development stream of GEF thus is quite mature and has a quite long history. And actually GEF is the base technology for everything that has to do with graphical editors under Eclipse. It's either used directly by a lot of people, but also indirectly via the GMF runtime and the graffiti frameworks, which actually built on top of GEF. Because this is the case, it has been a high concern to guarantee a stable API for all users of GEF. And this has led to the fact that there haven't been any breaking API changes for the GEF source code since 2004 when GEF 3.0 was released. For Zest, it's the same since it joined GEF in 2007. In the last year's development frame, so for Juno, we have basically tried to get GEF on the line and ready for the new common build infrastructure at Eclipse. So we have ported everything to Git. We have a Maven Tycho-based build now in place. You can consume nightly builds from hudsoneclipse.org as well as weekly integration builds and so on. So those who rely on GEF 3.x and Zest 1.x can rely on a stable infrastructure that will remain in place. But the problem is that as the history is quite long and as there haven't been any API breaking changes, the API is quite organically evolved, and we have a lot of bugzillas, feature requests, which we can actually not deal with without breaking the API. I just give you some topics that would be of interest for us, but which are not realizable without breaking API. The first and foremost thing is that the componentization, so the distinction of GEF into 3 modules, Draw2D, GEF, model view controller, and Zest, is somehow historically based. It's because Zest was the last component to join, but one could really rethink this modularization and organize the things from a technical perspective. Then a big issue is native support for the E4 application model. With the current infrastructure, GEF pretty much relies on SWT and it pretty much relies on the Workbench UI. So you can actually not realize any native E4 graphical editor with the current GEF framework because of the dependencies it has on the Workbench UI. Then there's important features missing in my eyes, such as support for rotation of figures or for other transformations, support for curved connections. If you look on the features that are actually requested in the mailing lists, and these are 2 very hot topics in there. One thing that has become important with respect to E4 is that we now want to have support for other rendering platforms than SWT, which is not possible with Draw2D at the moment because it's hard coded to be based on SWT, and it reuses SWT classes in certain contexts. Then things like multi-touch gestures is something that cannot be supported with the current API restrictions. And there are some things in the internals of GEF which could be reworked as well, besides various restructurings in a detail level that we can think of. So the ZEST committers that we have came to that conclusion that something new is needed already in 2010. And they started a provisional component, which they called ZEST2, to develop the next generation of the ZEST API. And the idea was to not replace ZEST, but to leave the 1.x version in its place and to start with ZEST2 in parallel. So all the people that rely on ZEST1 can start or can continue to consume it. It gets maintained, but new features are developed in terms of ZEST2 in an own Git repository and via an own update site. And the API within that project is regarded to be provisional, up to a final graduation, which is actually not or wasn't planned at that point. For the Draw2D and the GEF MVZ components, so model view controller components that make up the other parts of GEF, we had something similar in mind, and we started a similar approach in 2011, which we call GEF4. And the intention was to have that quite analogously to what ZEST2 did. So develop the next generation API for Draw2D and GEF in parallel to maintaining the current 3.x stream, providing it on an own update site, residing it in an own Git repository. And our plans before the 3.8 release was that we should start with developing a new double precision geometry API, because the one that is contained in Draw2D is a mixture of integer and double base precision, and it's quite messy and not good usable and very limited. And our idea was, if we want to enable people to deal with transformations and more complex graphical stuff, then we need a profound geometry API to perform geometric calculations. So that is what we started on. And the idea was then to migrate the remaining code base of Draw2D and GEF MVZ after having completed that. So ZEST2 and GEF4 were initiatives which basically were evolving parallel to each other. And then we talked with each other and we thought it would be a good idea to join these efforts. So we agreed on having just one single initiative after the Juno release, and that means that we want to merge GEF4 and ZEST2 to just a single approach, and we decided to call it GEF4 because that denotes that we are developing the next generation of the overall GEF project within it. So our detailed plans were that we have a unified approach with a shared code base and just a single namespace for all plugins that are in there, which make these plugins visible as part of the GEF4 approach. So all the plugins that we are going to develop in the new stream will have that prefix org Eclipse GEF4. Because we think that that makes it clearer for consumers to distinguish between the GEF proper, so the 3.x, respectively ZEST 1.x branch that we still maintain, and the new provisional components where we want to try a new API. And we thought in bringing the two approaches together, we not only have the chance to develop or restructure each individual component, but to rethink the overall modularization as a whole. Because, as I already said, in most places it's only historically justified. And we did so. So the current status quo is that we started actually developing such a geometry component, and we finalized work on it, at least for now, with the Juno release. We gained quite some functionality in that, and I'll give you a short overview on what we have realized there. We are also getting mature in the sense that we have quite a few units test already in place, And I think we'll increase that in the coming months as well. So the next thing that we intended was to start migrating the other parts of Draw2D and GEF, and the logically next component, if we rethink the modularization while doing so, was to start with a graphics abstraction that allows us to use the geometric objects that we have to render them on a canvas. So we started directly after the Juno release to develop this graphics component as a second one. And I'll show you a bit its current state also today. Let's start with GEF4 geometry. So the first component that we started in the GEF4 branch, which does not anymore have this distinction into low and high precision API as Draw2D had that, but we just have a double-based API. And we have some built-in imprecision. So all calculations are performed as precise as possible, and all comparisons are performed in an imprecise fashion. So we can cope with rounding effects that you normally run into if you have, if you perform double-based computations. So if you compute an intersection point between two straights, for instance, and you later perform a containment check, then that actually the intersection point is reported to be contained by both lines that you intersected, things like that. We have three basic packages within this geometry component. One for Euclidean computations, which basically provides a vector and a straight abstraction. One for projective geometry, which allows you to perform 2D computations based on 3D vectors. And a planar package, which contains the usual geometric abstractions, geometric objects that you need to perform calculations in a 2D space. If you compare that to what SWT provides and what Draw2D provided and what is provided by Java 2D, for instance, then you see that we have a few specialties in there. For instance, we have some Bezier curves, so we are not limited to second or third order degree Bezier curves, but we can deal with arbitrary ones, and we have support for things like curved polygons or regions and rings. Ring is a combination of polygons, actually. And we have built-in conversions from our geometric objects to AWT, so basically to Java 2D geometry as well as to SWT. And we have refactored out all direct SWT dependencies. So all these conversions are placed in separate plugins, and you can use the geometry component without any hard-coded dependencies on SWT. Yeah, some features I already named. We have support for arbitrary Bezier curves, for curved polygons. We can perform a few approximations and interpolations. We have tried to define the API in a sense that we have some core abstractions like curves, like shapes, like multi-shapes, which have a clear, concise API, so you can touch each geometry with another one to see if they have at least one point in common. You can intersect all curves, you have containment tests for all shapes and so on. Besides these core abstractions, which are designed as an interface hierarchy, we have some abstract base classes which are related to the construction of the shapes. So for instance, we have abstract rectangle-based geometry that is used for all these shapes that are created by means of a rectangle. So even if we construct an ellipse, which is basically, or let's say an arc, which is actually a curve, this is an abstract rectangle-based geometry because we describe it by means of a rectangle. Yeah, we have built-in direct support for transformations in the 2D space via distinct interfaces. And as I already said, we don't have any hard-coded SWT dependencies left. To give you an overview on the classes that we have, you see these basic abstractions that we provide. On the right-hand side, the shapes that we support, on the left-hand side, the curves that we support. The thing I should mention is that Bezier curve is no abstract class, but the concrete one, and quadratic and cubic Bezier curves are just special cases. We have support for polybeziers, which are curves consisting of multiple Bezier curves. And I think everything else besides maybe the curved polygon and the region is the same that you would expect from any geometry toolkit like Java 2D as well. just that we have this built-in imprecision that Java 2D doesn't have. This geometry classes, as I said, provide certain abstractions that are fulfilled by all curves and shape respectively. So you can query each shape to return its outline as a curve, or the individual segments of its outline as an array of curves. You can perform containment checks on shapes with all geometries, and you can do an intersection test if two geometries have some point, I say, in common via this touches method. And you can compute intersections and overlaps for all curves. So we tried to make that as consistent as we could. And as I said, the base classes that we provide are motivated by the kind of construction we have for each of the shapes. So you can, if you want to extend the geometry API with new abstractions, then you can easily do so by hooking into the respective abstract base classes that we provide. Just to give you an idea what is currently there, we have built a couple of examples, and let's simply show that to you. If you check out the GEF4 code base, then that is what you can basically see right now, is a couple of plugins dealing with geometry, a couple of plugins with the graphics component we are currently working with, and there's this example plugin in the two where we have built in some demos, for instance, to depict how Bezier curves can be constructed. So you can move things around, you can see how they are constructed. We have something for depicting how interpolation is done, so you can customize everything that the algorithm supports there. We have examples depicting how triangulation of complex polygons can be performed. I think these examples might help to get an impression what is currently supported. We also have distinct examples for all the intersection possibilities and the constructive area geometry that is supported, so you can see how the API can actually be used in detail. Just to give you a bit impression on how source code looks like, this is just a glance. I don't want to go into the details, but just to show you that these abstractions are built to well interact with each other. So you can query each shape for its outline. You can approximate all curves as Bezier curves and so on. We have means for interpolation of cubic curves and so on. The second component we have started after completing the geometry component now is the graphics component, where we intend to support the rendering of the planar geometries of our geometry component, as well as images and text directly on some underlying canvas. And we wanted to do that independent of the toolkit that is actually used. So we wanted to have a graphics that is independent of AWT or SWT or any other one. I just marked with this asterisk here, Tom Schindel has already prototyped the graphics based on JavaFX, and we saw that it fits quite well too. That of course makes it necessary that we have some key abstractions within the graphics component to represent things like fonts, like images, like colors, and so on. And something that disturbed me when working with the graphics abstraction in Draw2D is that this graphic has a lot of properties that you can customize. Things like anti-aliasing, things like line width, and so on. And you really don't know what the implication is. So is that used during drawing of shapes, during fill? Is it just used for rendering text and so on? And therefore we thought we need to group properties. So we have certain properties that the canvas or the graphics supports, and we group them together. So we have properties that are relevant for all draw operations or for all fill operations and so on. We also try to build in a full push-pop restore of the state of a graphics object. So you can push a current state of the graphics to a stack, deal with changing the properties and restore the state or pop it back. Something that is not completely supported by Draw2D, because, for instance, if you have a clipping region which is no rectangle based but which is based on paths, then that is not supported by Draw2D anymore. We try to do that for arbitrary states of the graphics component in this new version. And we have currently started to work on a basic infrastructure to support a basic image processing, so pixel filter or channel filter based operations. So you can realize something like grayscaling, blurring, and so on with images, independently of a certain toolkit. As I already said, we tried to factor out these properties into meaningful groups, so you can easier identify what are the things that you have to manipulate and what are the properties that you can manipulate in order to influence how drawing of shapes or filling of shapes, for instance, is performed. As I said, we are still developing this component, and I think one thing that is important, we will need to support or provide better support for doing calculations based on fonts, because that is something that is quite nasty at the moment in Draw2D as well. But that is something that is quite complex and will probably take us quite a while until we see what is really there. Up to now, we just have started with some first implementation, and I showed you two examples here. The left one is an AWT-based version of our graphics, and the right one is an SWT-based version. And you see that there is not so much a difference. So our intention to just have a single API and to target different toolkits is something that is not so obscure. You can also take a look at these examples. There's a graphics examples plugin. If you check out our code base, then these examples are there as well. So we have this simple example as well built, and then you can see how this graphics API is intended to be used there. Yeah, just to give you a short impression on how this can be used, I think that's basically what you would expect from some graphics abstraction. You can fill, you can draw, and you can deal with text and images. And that's basically where we are. So we try to complete this graphics implementation and start with a canvas abstraction. So you have something like what is the core actually of Draw2D, like a figure canvas and figures as abstractions in a time frame that is somehow around the Kepler release. We will shortly start with migrating the complete SES2 code base into the GEF4 repository. We will move everything that is located under the SES2 repo into the GEF4 repo. We will put it on the update side, and all the SES2 plugins will be migrated to the GEF4 namespace. We will not start with adopting the code base of SES2 until we have completed this canvas component and we have everything in place so SES2 can be completely hooked on the new GEF4 components. Up to now, there's still stuff in Draw2D which is needs that we cannot provide. So then the next thing on the long term will be to actually start with adopting the ZEST components. And after we have done that, we want to then start with migrating the remaining parts of Draw2D. There's still something that is not covered by these geometry, graphics, and canvas components, which we intend to create. And we will then start also with porting the editor abstraction, so GEF MVZ. While doing so, we want to remodularize everything, and especially with respect to GEF MVZ, we want to factor out all the Workbench UI dependencies so you can use GEF to build applications for E4 with it. On the very short term, we are actually implementing image toString currently because we thought that to be a nice feature. And I thought that to be a nice conclusion for this talk. So thank you for your attention, and if you have questions, I think we have some 3 or 4 minutes left to answer them. Okay, the question was whether we want to support some test infrastructure, so people who implement against our framework can make use of it to test the application. Actually, with respect to the current components that we provide, they are still pretty basic. So we have unit tests in place to test them locally. As soon as we go into the rendering, we will definitely need to do something to test our own components. I think what you are asking is pretty much dealing with editor testing and so on. And I think that is quite far away, at least from where we are standing right now. I think there are a couple of interesting approaches in the Eclipse ecosystem already, like SWT-bot or others. And I think we will have to see how we can bring GEF better to deal with that also when going further here. So that is something we have in mind, but which is quite far away on the roadmap, because the GEF editor components will be the last that we will have to or can migrate. Yeah. Yeah. That is one of the plans that we have in mind with respect to remodularization, because we have some layouting in Draw2D and we have some layouting in Zest. And to me, the separation doesn't make any sense. So that it is separated and that it has to stay separated in the 3.x stream is because of API restrictions. But as soon as we are free of them, and that's the case here, we really want to rethink that. And I'm thinking of a complete layouting component which can comprise these things. Yeah, that's something I have in mind. Yeah? No, we will not support any 3D. I think the scope of the framework is clearly 2D, rendering 2D editors, and I think that's a lot of work to deal with 2D already. So 3D is not on our plans. Okay, I think it would be impolite to the next speaker to continue. If you have any questions, you can find me outside or go to our itemis booth and you can find me there as well. Thank you very much.